Hey, how are you doing today? Today we're gonna make something really cool in Unity. We're gonna make a trajectory predictor, just like in the Angry Birds and other similar games. I will be doing this from scratch because if I don't and start from the middle, you might get confused and say, what the heck is he doing? So let's get ready for the ride and let's begin. So I have a new project here, complete blank project. There's nothing here. So I'm gonna go to game and select the free aspect. Now go to window, asset store. Here in the search bar, select for 2D sprite pack. Select this one. This is from Unity itself and it's totally free. Click import and you can import them all for this sample. So it's gonna take some time to download. Here they are. Okay, now we have the assets. Let's set up our scene. Select the sky sprite here and drag it. Scale it to more appropriate size. Okay, now drag the grass thin sprite and place it here. Now add a edge collider component to the grass and let's set the collision course to here, more to the ground. Okay, looks good. Now go in the assets folder and create a new folder for our prefabs. Drag the grass thin sprite to our prefabs. Okay, and drag the grass thin sprite again to over here. Let's make sure they're both at the same level, especially on the y-axis. Okay, looks good. I'm gonna stretch it over here. Let's see how it looks in the game. Okay, right, we got the grounds. Now let's make our targets. Go in the sprites folder and drag the plank sprite in the view. Let's resize it a bit. Rotate it to 90 degrees. Add a rigid body 2D component as well as the box collider 2D component. Let's rename it to just plank. Let's make the plank a prefab. And now let's duplicate the plank to make it look like a tower. Control D, D, hold shift and drag it to over here in the ground, and again place it here. Let's bring it a little down, hit Control Save and let's run the game to see. Right, this is going to be our target tower. Now let's create our shooting object, which is going to be an asteroid. Select it and drag it over here. Let's change the order layer for the rock object to 1. Rename the object to rock and add a rigid body 2D component to the rock and a circle collider 2D. Okay, now this is our shooter object. So let's test the physics by running the game. Okay, here is the ball. Now go back to the scene and let's select the rock and place it right here. Yes, our physics is working just fine. Okay, now it's time to set up our slingshot. In the assets folder, in the sprites, open the catapult sprite by clicking here. There are two parts of it, so let's drag the left part here. I'm gonna scale it a little bit, looks fine. Now drag the second part and give it the same size. Now position it to the best match. Looks fine. Now create an empty game object and name it Slingshot. Drag both of these parts and make this object their parent. Now I'm gonna rename them. This is Slingshot right and this is Slingshot left. Okay, now is the important part. Let's place marker on these slingshot handles where the slingshot rubber will be pulled from. So I'm gonna click slingshot right and I'm gonna add a empty game object. I'm gonna name it right. It is placed here, and simultaneously I'm gonna add a empty game object to slingshot left and I'm gonna call it left. So you can better see it, let's add some tags. This is right and this is left. Oh, and this is left. Need to position them a little bit. Left is here and the right is here. That's more like it. Now select the slingshot parent object and add an empty game object. This is going to be our rubber right. Select the rubber right and add a new component, the line renderer component. Let's drag it to over here and set the shadow bias to 0. I'm gonna set it here to 0 and the second one to 0.100. So the rubber is going to be black, so let's create a black material. I'm gonna go create a folder and name it materials. I'm gonna right click, create material. Let's name it rubber shade. So quickly go to the shader, legacy shaders, transparent, diffuse. I'm gonna set the main color to black. Go in the rubber right and in the material drag the rubber shade material to over here. Let's tag it so we can see it. We don't need to worry about where the rubber is placed. So what I'm gonna do is I'm gonna create a duplicate copy of this rubber right and rename it to rubber left. I'm gonna set the tag to some other color. Now select the rock and if you place it here, so it doesn't feel like the rock is positioned inside a slingshot. So what I'm gonna do here, I'm gonna select the slingshot left and set the order to 1. So now it feels like the rock is placed between the slingshot. Okay, now the scene is set up. Let's move to the code part. So make it super easy. Right click on the assets and create a new folder. I'm gonna call it scripts. Now inside the script create a new C# script, call it rock. Similarly create a new C# script, call it slingshot. Now create a script, called enums. Firstly, double click the enum script. Now open in the Visual Studio. So what I'm gonna do here is I'm gonna remove it all, and I'm gonna write namespace assets.script, and I'm gonna write public enum rock state, and this is going to be before Crown and Throne. I'm gonna declare a new enum. Is going to be public enum I'm gonna set it idle state pulling and flying. Okay, now let's go to the rock script. What you're gonna do here is when the game starts, we're gonna disable the rock rigid body so it's not affected by the gravity and stays still on the slingshot. So I'm gonna take a reference here, private rigid body 2D RB, and in the start function I'm gonna write RB equal to get component the rock's rigid body 2D component RB though is kinematic equal to true. So is kinematic true, it means the gravity will be disabled on the start of the game. So let's take a reference for the rock state, public rock state state get and set. On the start, the state is going to be rock state dot before Throne. Remove the update method and write a method here, public void on throw RB dot is kinematic equal to false. So when the ball is thrown, so the gravity will be applied on the rock. Then I'm going to set the state to rock state dot thrown. So this method will be called when the user releases the slingshot and the rock is gonna fly sky high. We're done in the rock script, so let's close it and take a deep breath. Okay, now let's add a rock rest position. So whenever the game is initialized, the rock will rest at the same position. So right click on slingshot, create empty. I'm gonna call it rock rest position. I'm gonna add a tag to it and select the move tool and move it here and right between the slingshot. Right, now we'll go in the slingshot script and take a reference for both of these rubber origins. So I'm gonna go in the slingshot script and I'm gonna take a reference, public transform left slingshot origin and the right slingshot origin. We have the reference for the origin. Now let's take a reference for the rubber itself, which is our line renderer. Line renderer slingshot left rubber slingshot right rubber. Now take the reference for the rock itself and its rock wake position. So it is public transform rock wake position, rock rest position, public game object the rock, and I'm gonna take public float throw speed. And also take a reference for the slingshot state. So public slingshot state slingshot state. Now we need one thing. We need a variable for the middle vector that lies between these slingshot rubbers. So when the rubber is being pulled here, we need a middle point for that. So let's declare private vector 3 slingshot middle vector. That's great. Okay, now the real work starts. So I'm gonna write the code, then I'm gonna explain. So in the start, the left rubber position 0. You see, at the start, I'm setting the slingshot state to idle. We're not doing anything. And then I'm setting the rubber position where we place the markers. You know, the left rubber is here, the right rubber is here. Okay? And now I'm calculating the slingshot middle vector by typing slingshot middle vector equal to new vector 3. I'm gonna call it left slingshot origin dot position plus x plus right slingshot origin dot position dot x divided by 2, and the same code for the y-axis, and z-axis will be 0. So now let's write some important methods to enable the rubbers. So I'm gonna call void set slingshot rubbers active boolean flag active slingshot rubber left dot enabled equal to active. The same thing for the right rubber. Now we're gonna write a method to display the rubber whenever the rock is being pulled by the user. So I'm gonna say void display slingshot rubbers I'm gonna say slingshot left rubber dot set position 1, and where the rock dot transform dot position, and the same for the right. Now I'm gonna write the method to initialize our throw. So I'm gonna say void initialize throw rock dot transform dot position equal to the rock rest position dot position by default, and I'm going to set the slingshot state equal to slingshot state dot idle, and I'm going to set the rubber active to true. So when you have started the pulling, we're going to show the rubbers. Okay, our methods are now set up. Now let's take a deep breath. We're going to move to the code where we handle user pulling the slingshot rubber. Now in the update method, we're going to see what is the current state of the slingshot. So write switch slingshot state. So this is where all the magic will happen. So if the state is idle, what we're gonna do? If it's idle, then we're gonna initialize the throw. Initialize throw, and we're gonna display the slingshot rubbers. And we're gonna see if user has started the pull process by clicking the left mouse button or finger and dragging it. So we're gonna check if input.get mouse button 0 means the left click is down. We're gonna see if the location is on the rock. We're gonna check vector3 location equal to camera.main.screen to world point input.mouse position. So this is where the user's finger is or the mouse cursor is. So now we're gonna see if the mouse position is on the rock. If the rock is the main object being pulled by the mouse, then, but before, you're gonna check if rock.get component, the circle collider attached to the rock overlaps with the mouse position. I'm going to say physics2d dot overlap point get the mouse position, and if it is overlapping with the rock, which means the rock is being pulled, we're gonna set the state to slingshot state dot pulling. So when the state is pulling, this case will not happen. We're gonna define the new case for the state of pulling. So I'm gonna say if the state is pulling, then what we're gonna do? We're gonna display slingshot rubbers, and we're gonna check if the state, if the mouse button is still being held down. Then we're gonna set vector3 location of the mouse position, and we're gonna set the rock's position to this location. What I'm doing here is wherever my mouse is, I'm taking the rock with it. So now I'm gonna go back in the scene. I'm gonna select slingshot, and I'm gonna drop the slingshot script to the slingshot, and I'm gonna select the rock, and I'm gonna drag the rock script to the rock. Before we move on, we have to set some parameters. So the left slingshot origin is this, and the right is this, and left slingshot rubber is this, and the right is this, and the rock rest position is this, and let's set the throw position to 7. So now let's test it out. Well, I forgot to add the rock here as well. So now let's test it out. Alright. Wow. Oh, well, we can see the rock because if you check the rock position, the z-axis is causing some problems. So z-axis should be 0. So we're gonna go back in the code where the initialized throw is, where we set the rock rest position. Let's set it to vector3 to position.x. Let's set it to only x and y axis only, and for z axis only 0. Okay, now let's go back and check again. If I click here and drag, right, looks nice, doesn't it? But there is a problem here. I can stretch it as far as I want. You see that? I can stretch it as far as I want. There should be a limit. So we're gonna go back in the code, and in the pulling state we're gonna check if vector3 dot distance, the location between the mouse position and the slingshot middle vector, is bigger than 2.5 f. This is the coordinate I found it appropriate. So then we're gonna set max position equal to location minus slingshot middle vector dot normalized into 2.5f plus slingshot middle vector. Then I'm gonna set the rock position to the max position. It won't go beyond that. And for the else part, we're gonna set the same position. Now let's go back in the game and test it. Well, as you can see, I cannot stretch beyond this point. So, looks pretty good. So now what's left to do? When we release the mouse button, the rock is gonna fly in the direction wherever the slingshot points to it. So, go back in the code, in the slingshot script. So when the state is pulling and the mouse is down, which means the user is still pulling the rubber. So if the state is pulling and user has let go of the mouse button, which means it is the else part, then we're gonna calculate the distance of how far the rubber was pulled by typing float distance vector3 dot distance, the slingshot middle vector, and rock's position. So if user has pulled the rubber for a considerable amount, it should be at least bigger than 0.5. Then I'm gonna set the slingshot rubbers disable because their purpose is complete, and then I'm gonna change the slingshot state equal to dot flying, and then we're gonna write a method to throw the rock. I'm gonna say throw a rock, and how far? The distance. Okay, so now let's write the throw rock method. I'm gonna say void throw rock float distance I'm gonna say vector3 dot velocity, not dot, the instance of vector3 is slingshot middle vector minus rock dot transform dot position, and then we're gonna set rock dot get component, the rock script we already bound to the rock object, and say the on throw the rigid body will become active, and then we're going to set the velocity of the rock's rigid body by typing rock dot get component rigid body 2D dot velocity equal to new vector 2, because it's going to travel in x and y axis, so it's going to be velocity dot x and velocity dot y into the throw speed and how far the distance. Alright, so now let's go back to the scene and let's test it out. Well, I think I set the throw speed too much. Let's set it to 5. So let's place it here and let go. Alright, the slingshot is working marvelously. So now what's left to do is to do what you all came here to learn at the first place. We're gonna make a trajectory predictor line to show you where the rock will go in which direction. Okay, so now let's begin.